In the final part of Module 5, we talk about the implementation of IIR filters using direct form 2 representation. The fixed point implementation for direct form 2 is more complicated compared to that of direct form 1. The developed direct form 2 implementation of the IIR filter is shown as in the diagram. In direct form 2, we realize that the delay elements will always be in the center and it is shared both for the numerator and denominator coefficients. The input is defined as x of n, the output is y of n. The intermediate value you have is called as w of n. From w of n, we can generate what is w of n minus 1, w of n minus 2 and so on up to w of n minus m by passing it through respective delay elements. Then these values could be scaled appropriately by the coefficients, which is a and b. As shown in the figure, there are two scale factors for capital A and B for the respective numerator and denominator coefficients. So these are designated to scale denominator coefficients and numerator coefficients to make it possible to represent them in the Q format respectively. Now capital S is the special scaling factor to scale down the input sample so that the numerical overflow in the first sum can be prevented. The difference equation describing the two stages are as follows. First, we get an equation for w of n in terms of the input x of n and the previous values of w of n, which is w of n minus 1, n minus 2 and so on. The second equation tells us how to get the final output, which is y of n, from the scaled version of w of n minus 1, w of n minus m and so on, which are scaled by the factors b0, b1 and so on till bm. This first equation is scaled down by a factor which is capital A to ensure that all the denominator coefficients happens to have a value which is less than 1. Or in other words, we obtain the value ws of n from w of n by scaling it by 1 by a. This equation could be implemented as 1 by a times x of n minus 1 by a times a1 of w of n minus 1 and so on. This is simply obtained from the first equation by dividing throughout by a, as shown by the equation here. In other words, from the above, we can say that Wn is a times of Ws of n. On similar lines, the second equation can also be taken, but this time it is scaled by a factor called as b. Therefore, ys of n is 1 by b times y of n, which yields the result 1 by b times every single term in the equation for y of n. In other words, we can say that y of n is b times of ys of n. Now, to prevent the first adder overflow, the scaling factor s can be determined using equation 1, which is repeated here for your convenience, where h of k is the impulse response due to the denominator polynomial of the IIR filter, where the poles can cause a large value to the first sum. Therefore, the equation for h of n is given as h of n is equal to z inverse of 1 by 1 plus a1 z inverse plus and so on till the last term. All the scale factors a, b and s are usually chosen to be a power of 2 respectively, so that this operation can be easily implemented using the shift operation and hence can be used in the coding process. Let us consider this example of the IIR filter to illustrate the concept. So the equation describes the IIR filter is as shown, which is in terms of the input terms and the passed value of output. The passband gain is said to be 1 and a full range of input can be considered here. We are asked to use direct form 2 implementation to develop the DSP implementation in Q15 fixed point system. The difference equations without scaling in the direct form 2 implementation can be arrived at from the first equation. And the two equations upon solving will be, the first equation is for W of n, the intermediate value, and second equation is for Y of n through the terms which is W of n. This equations can be obtained through a very simple simplification procedure. To prevent overflow in the first adder, we obtain the reciprocal of the denominator polynomial as a of s is equal to 1 divided by 1 plus 1.52 z inverse plus 0.64 z power of minus 2. Here we choose the s factor to be equal to s is equal to 16 and we choose a is equal to 2 to scale down the denominator coefficients by half. Since the second adder output after scaling is given as ys of n, we get the scaled values as 0.75 by b, 1.49 by b, 0.75 by b respectively. And this comes from the second equation after scaling by b. To avoid the second adder overflow, we have to ensure that each coefficient has a value less than 1, along with the sum of the absolute values. So, the sum total of all these terms should be less than 1. Hence, the value b is equal to 4 is chosen for this purpose. We can develop the DSP equations for the above as follows. The term xs of n is obtained by scaling x of n by 16. The equation for ws of n will be as follows after performing the scaling operation. The relation between w of n is 2 times of ws of n, and the equation for ys of n after scaling will be as shown here, and the equation for getting the final output is by scaling ys of n by both b as well as s. So the product of b and s will be equal to 64. So 64 multiplied by ys of n should be your final answer. So you are scaling it back to restore the original value. With the help of these equations, we can very easily implement the code for the DF2 realization of IIR filter using the DSP processor. At the end of this module, we have presented some questions for review. These questions are from the model question paper for the subject. So we can see the distribution. The first question is addressing the block diagram to explain digital signal processor, which is based on the Harvard architecture. The question is asked for 6 marks. It's a theory question. The 3 blocks, namely mag, shifter and adder, Address generation has been asked for 10 marks in total. A simple conversion, two decimal values are given, one negative, one positive. Convert to Q15 format, totals 4 marks. Examples for FIR filter, the equation is provided, the gain is mentioned. This is a problem which has already been discussed. It is for 6 marks. To discuss the formats of IEEE floating point, single precision, double precision, totaling 6 marks. With a diagram, explain basic architecture of TMS 320C's 54XX. The total is 8 marks. So most of the questions have been appearing from within the prescribed text. Thank you all.